Hi everyone, my name is Sam, and today we're going to be learning how to solve for both the arc length and the area under a catenary.
Okay, so first let's take a look at our problem. So in this case, our problem is a telephone line is catenary described by y equals a cosine h x over a. Find the ratio of the area under the catenary to its arc length, and just disregard the last portion. We don't need that. So basically what we're being asked to find is both the ratio of the area under the catenary as well as its arc length. So before we even get started with the problem, let's define what a catenary is first. So a catenary is basically a curve of uniform density that is perfectly stretched and is hung from 2 points, something like a telephone wire. So in layman's terms, it's just a curve. So catenaries, which are type of hyperbolas, have their own unique identities. So here we take a look at the identities, and this one here is especially helpful, and we'll use it later on. They also have unique derivatives. So if you remember, the derivative of sine and a normal of a sine of a normal function is cosine, and the derivative of cosine of a normal function is negative sine. Well, in this case, for hyperbolic functions, the derivative of sine is cosine, and the derivative of cosine is sine. So they're similar, but at the same time, they're a little different.
Okay, so if you remember correctly, the two things we have to solve for are the area under a catenary as well as the arc length of the catenary. So I say we start off with the area under a catenary first, since it's much easier. So basically, to solve for the area under a catenary, first we're going to take our function that they gave us, which is y equals a cosine h x over a. And to solve for the area under a catenary, all you have to do is just find the integral of your function. So it's a basic integral. We're going to write it in this format here, plug everything into this formula. We're going to, what you can do, instead of taking the integral of this a, which is going to only make your life harder, one rule that we have for integrals is that you can just take this a out and put it in front of your integration symbol. And so now on this line we're all set to go. So all we have to do is try to find the antiderivative of cosine h, which we all know is sine of h. And from there we have this function now, a sine h x over a, and we have to evaluate it through points d and c. And the way we do this is we use the fundamental theorem of calculus, where we take the top term, which is d, and subtract it by the bottom term, which in this case is c. So all we have to do is just plug it in, and we will get this as our final net result. Okay, so now let's take a look at how to solve for the arc length of a catenary. So the formula for solving for the arc length of a catenary is the integral of the square root of 1 plus f of x squared. So in this case, we can write the integral of the square root of 1 plus a sine h squared x over a. So remember that special rule I told you to remember from before? Well, it'll come into use here, since cosine h squared a minus sine h squared a is equal to 1. So therefore, we can make cosine h squared a equal to 1 plus sine h squared a. So that'll make our life a whole lot easier when we won't have to deal with this 1 anymore. Instead of having 1 plus a sine h squared a, we can just have a cosine h squared x over a. So from here, it's just simple integration. So first, we can just take the square root of this whole thing to eliminate that radical sign, and we'll just end up with the integral of a cosine h. From here, we could just use substitution. So in this case, I made my u equal to x over a, and then the derivative of that, du, will be equal to 1 over a. And then from there, we can make a du equal to 1, since we can just multiply by a on both sides. So from here, we can just plug in a du times cosine h, and then just find the integral of that. So whenever we find the integral, our du is going to cancel out, and we have to find the antiderivative of our cosine h, which we know is sine h. So we're left with a sine h x over a, and we can use the fundamental theorem of calculus once again to get the same expression as we got before. So therefore, for finding our ratio of the two answers, it'll be a 1-to-1 ratio, since both answers will be exactly the same. And that's it.